Welcome everyone. Today we're going to see about kernel architecture, the different types, advantages and disadvantages of them, and differences between them. So, what is a kernel architecture? What a kernel is basically. So, a kernel is the lowest level software that can be easily replaced, and it acts as an interface between the hardware and the user. Uh, let's see the diagram given below. It is acting as a bridge between the hardware and the user mode. The hardware contains the main memory, the CPU, and the peripheral devices. All these are being connected through each other through the address, data, and the control buses. Then it is followed by the kernel mode. The kernel mode will have various services in it, like virtual file systems, IPC. IPC is inter-process communications, scheduling, and all. We'll have several other services like them, and then in the user mode, you have libraries in which the program like user program, application programs, system programs are being saved. So the hardware and the user mode are being connected through the kernel mode. Let us see different types of kernels. There are of course different ways to build a kernel based upon the architectural considerations while building from the scratch. So the kernels basically falling into three different categories: the microkernel, monolithic kernel, and the hybrid kernel. Microkernels are taking the approach of managing only the CPU, the memory, and the IPC, so that the kernels are broken down into separate processes, and these processes are called as servers. So the servers, some servers run in the kernel mode while some run in the user mode, and they are kept in different address spaces. The communication in the microkernels are done via message passing, and this message passing is called as inter-process communication. It is one of the services among the kernel modes. Okay, the advantage of separation allows them that if in case one server fails, it does not affect the other servers, and the system keeps functioning efficiently. Examples of microkernels are Mac OS X and the Windows NT. Okay, let us see about the. So this is the architecture of microkernel architecture. In this, you have a hardware and an application. Both these are being interfaced through the kernel and the user mode. Over here, what you do is you have few services in the kernel mode and few services in the user mode. The kernel mode is more handled by the IPC, basic IPCs, and the virtual memory and scheduling. These are the services being allowed in the kernel mode. And you have application IPC, Unix server, device driver, and file servers in the user mode. Denote that the device drivers are in the user mode, and this makes the processes quite slow, and the hardware tends to lag because of this. Okay, then let's discuss about advantages and disadvantages. Advantages is that it has a higher portability. Like if you want to change the video card or operating system, you don't have to worry about it unless and until the operating system can try to access the same way as before with the hardware. And you have very small footprint for both the memory and to install spaces. Then comes security. It has high security um, because because of the separate separate address space. It provides high security to them. And then disadvantages. Since the hardwares are being abstracted through the device drivers, this makes the device and the device drivers, as I told, are present in the user mode, may tend to make the hardware react slower, and the process have to wait in a queue to get information. Multitasking cannot be done over here, and it takes more time. Process lags are being found over here, and you cannot access other processes without waiting. So, monolithic kernel architecture is quite opposite of microkernel architecture because it makes use of only the kernel space and it does not include any services from the user space. So it has only a single address space and all the services exist and execute in the kernel address space. Just because of this property, it is called as a single static binary file. And examples of kernel monolithic kernels are Linux and Unix. Okay, they just not make use of CPU, IPC, and memory, but also incorporate device drivers, file system managements, and system service calls, etc. They tend to have better access towards the hardware, and multitasking is made possible because if you want to access a program and you want to get information from the memory and you also want to run another process, you can do it through a direct line and you don't have to wait in a queue for things to be done. And multitasking is actually going to be a risk, like a risk factor, because if you don't have much technical knowledge and if things are to be run in the supervisor mode and if it's not being dealt properly, you can damage the system. You know what they do, the operating system is being used like written as a collection of routines so that each routine can call any other routine whenever they require it. Okay, and each routine is compiled in the build up time and they are all linked together in a single program which is called as a operating system kernel. Okay, when this is being like when the operating system is getting started, the kernel is getting loaded into the memory. So and then it runs in the kernel mode, all the services get executed. Okay, it also has a disadvantage that, as I told before, all paths are visible to other paths in the kernel mode. And if there is a, for example, just take if you have a bug in one part, and what happens is it spreads to even other parts and the data get damaged. In order to forsake this idea, in order to like develop a solution for this problem, what they did was all the routines, like many of the routines and the data structures were kept hidden, and whenever other routines required them, they were allowed to make use of this. This is going to be the monolithic kernel operating system architecture. Over here, you will have all the functions, all the services in the kernel mode alone, and you do not make use of the user mode. Over here, the different functions are virtual file system, different services are virtual file system, inter-process communication, schedulers, virtual memory, device drivers, dispatcher, and then what you do is you come to the application part. You get interfaced with the hardware through this kernel mode. Okay, so let us discuss about the advantages and disadvantages of using kernel architecture. Now, since the kernel architecture is becoming direct access to hardware for the program, like more direct access to the access these programs, correct? And what they make, like they make the process become easier. They can communicate easier with each other, and then the process reacts faster as well, because it doesn't require a queue time or it doesn't have a waiting time. So and they are faster as the services such as memory management, file management are all implemented in the same address space. Disadvantages are that if any one service fail, the monolithic kernel entire, like the entire operating system gets um, becomes a failure. And also, if you have to add a new service to the operating system, then you have to modify the entire operating system. That is, you have to recompile the operating system, which is actually quite tedious job. Let us see a few differences between monolithic and microkernel architectures. Monolithic architectures were basically the first architectures that were to be developed. Later then, microkernels were developed in the later years of 1980s. Then was hybrid kernel architectures being developed. Example of monolithic architecture are Unix and Linux, as we know, and examples of microkernels are QNX, L4, Herd, Symbian, etc. So monolithic kernels are faster than the microkernels. The first version of microkernel that was developed was 50% slower than the monolithic kernel, and the latest version of microkernel is 2 to 4% slower than the monolithic kernel. And to a point of fact, even the hybrid kernel is much slower than the monolithic kernels. As I told before, in the monolithic kernel, the the device driver is residing in the kernel space, and this makes it less secure. Um, Whereas in the microkernels, you have the device driver in the um, user space, and this makes it more secure and giving it an added advantage to be used in military devices to store confidential information, and the data can be highly secured. Then, in monolithic kernels, we make use of signals and sockets to ensure the IPC is done proper. Whereas in the microkernel, the approach is based upon the message queues and all. And when you have to add an information to the monolithic kernel, it is going to have the entire recompilation of the operating systems, whereas in microkernels it is very easy to add or remove any features without even recompiling the OS. So next we're going to discuss about hybrid kernel architecture. Hybrid kernel architecture is nothing but the combination of best outcomes of monolithic architecture and microkernel architecture. So hybrid kernels have the ability to pick and choose what they want to run in the user mode and what they want to run in the supervisor mode. This is actually done by the device manufacturer. So what they do is, most of the time they make the device driver and the file system to be existing in the user mode, and the IPC and the server calls to be existing in the supervisor mode, so that they give the best outcomes of both the monolithic and the microkernel architecture. Uh, and as I told before, this is being done by the hardware manufacturer, and it is their responsibility to maintain them, to maintain the driver well. I have attached the last slide as a comparison of architecture between the monolithic, microkernel, and hybrid kernel. In this, first comes the monolithic kernel. Over here, the red part is the kernel mode, and the yellow part is the user mode. In monolithic, all the services come under the kernel mode. Um, these services include VFS. VFS is virtual file system call, and then you have IPC. IPC is inter-process communication, file systems, schedulers, virtual memory, device drivers, dispatchers. Even there are few more services that could be added to them. And then you have microkernels. Over here, what they've done is they made use of the kernel mode and the user mode. In kernel mode, you'll have basic IPCs, virtual memory, scheduling, and all. And then in the user mode, they have the major part where they have application like services like application IP, see Unix server, device driver, file servers, and all. But this gave them a process lag. So then they again found and developed another version called the hybrid kernel, where they even provided a secured background as well as quite faster when compared to microkernel. Over here, what they did was they combined the IPC, the basic IPCs, the virtual memory and the scheduling with the application IPC, the device drivers, and what they did was they kept the file server and the Unix server in the user mode itself. They didn't make use of them. This made them provide a better um, this made them provide a better security. Okay, I guess this session was quite informative to you. Thank you.